Hello and welcome to this Reigate College Further Maths video looking at expressions we can form for cubics and quartics using the coefficients that we've looked at in previous videos. So if we look at this information you've been given here, we'll take a fairly easy example just to show what's happening, and then we'll get on and use these particular questions. So if we want to know what alpha squared plus beta squared was for a quadratic, if you think of starting with alpha plus beta all squared, so alpha plus beta all squared, that would be equal to alpha squared plus beta squared plus 2 alpha beta. So if I wanted to know what alpha squared plus beta squared was, I could just rearrange this expansion. So each of these statements here comes from rearranging an expansion. You can probably imagine if you expanded alpha plus beta plus gamma all squared, you would get lots of terms. You'd get alpha squared, beta squared, and gamma squared, and you would also get these ones here. So you can derive these and you may be asked to do some of the easier ones. So the question might say, show that this is true, and you would just rearrange this. If we wanted to show this, that 1 over alpha plus 1 over beta was equal to that, then we would add these together as a fraction and we would end up with this expression. The more complicated ones for the quartics, they will very much guide you through getting to that point, or they will say using the fact that this is equal to this, or for this quartic here. So you don't need to remember those exactly, but you need to be familiar with them. So let's look at how this works in practice. It's a little bit of an exercise in algebra is the way to think of this. And if you go on to looking at more advanced work on cubic and quartic equations, then you would use this theory. So here we've got an equation, x cubed plus x minus x squared minus 4x minus 3 equals 0. And we're not to solve the equation, but we've got to find alpha cubed plus beta cubed plus gamma cubed. So the first thing would be to identify that this is ax cubed plus bx squared plus cx plus d equals 0. So identify the value for each of those letters. So A is 1, B is minus 1, C is minus 4, and D is minus 3. So we've started off with that. We are now looking for alpha cubed plus beta cubed plus gamma cubed, and we are looking at a cubic equation. So if we look here for a cubic equation, here we're looking at this expansion here. So we know that alpha cubed plus beta cubed plus gamma cubed is equal to the sum of the roots cubed minus 3 times alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha, plus 3 alpha beta gamma. And you're not expected to derive this without some help, so they would guide you into getting to this expression here. So we want to find out what this is equal to, so we need to use expressions we know for the sum of the roots in pairs, and the sum of the roots in threes. So let's remember how that works. The sum of the roots, alpha plus beta plus gamma, is minus b over a. So that's going to be 1 over 1, so that's just equal to 1. The sum of the roots in pairs, which I'm going to write as alpha beta, the sum of the alpha betas, is c over a. So that's going to be minus 4 over 1. And we also need the sum of the roots as a 3, so the sum of alpha beta gamma, so minus b over a, c over a, minus d over a. So that's going to be minus that, so that's going to be 3. So now let's fill in what we know into this expression here. We've got alpha cubed plus beta cubed plus gamma cubed, which we're trying to find the value of, is equal to the sum of the roots cubed. So the sum of the roots is 1, so that's 1 cubed, minus 3 times the sum of the roots, which is 1, the sum of the roots in pairs, which is minus 4, plus 3 times all 3 roots multiplied together. And when we work this out, we get 1 plus 12 plus 9, and that is equal to 22. So that is the answer that we're wanting here. So these questions, like I say, often an exercise in algebra. Now let's look at this next question, which is deriving a new equation with roots related to a previous equation. So we've got new roots of an equation in W are going to be 2x minus 1, so 2 times the old roots take away 1. So that's what we're told that we need to achieve. So we set off by rearranging this to get x equals. So we've got x is equal to w plus 1 over 2. We then substitute that into the original equation. So we've got w plus 1 over 2. Make good use of your brackets here, all to the power 4. Plus 6 times w plus 1 over 2, and that's cubed. Plus 7 times w plus 1 all over 2 plus 8 equals 0. We now want to get rid of the fraction on the bottom because we want to have integer coefficients. Now 2 to the power 4 is 16. So we're going to multiply all the way through by 16. That's the next step. So when I multiply all the way through by 16 here, I get w plus 1 to the power 4 plus, so multiply this by 16. Remember that's 2 cubed, so that's 8. So this becomes 12 w plus 1 cubed plus, multiply all the way through by 16 here, that 2 is going to cancel to give me 56 w plus 1 plus 8 times 16, which gives you 128 equals 0. We then need to use binomial expansion or Pascal's triangle to multiply these out. So my tip for this is to write it in the following way. So this expanded out is w to the 4th plus 4w cubed plus 6w squared plus 4w plus 1. So that's that first bracket expanded out. The second bracket expanded out is just going to have w cubed, w squares, w's and 1. So when we expand this bracket here, either do it using Pascal's triangle or do a binomial expansion, but that is going to be 12w cubed plus 36w squared plus 36w plus 12. This one here, we're just going to multiply by 56, so that's 56w plus 56, and then we've got our 128. Then we can add those together, and by writing it in this way, we've got similar terms, like terms, stacked underneath each other. So I get w to the 4th plus 16w cubed plus 42w squared plus 96w plus, this adds up to 197, and that whole thing equals 0. So this equation here, you could test this, you can double check this is right, w to the 4th, this equation here will have roots related to the original one in this way. There's another method for doing this in the textbook, which is useful if the transformation of the roots is not linear. But you are not required to do that in the syllabus, and it's a much longer method, so we won't be looking at that method here. But there is a second method for solving these particular questions. Also remember, when you're doing these expansions, if you're not familiar with it, you can use Pascal's triangle. So if I want to do this expansion here for Pascal's triangle, you're going to use 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is the expansion line for the coefficients of w plus 1 all expanded out, and you can use those as the coefficients. If you don't know Pascal's triangle method there, then look that up, because that is quite a useful way for multiplying out brackets like this quicker than binomial for these particular examples.